name is Craig and welcome to Peri Solutions. In today's video, we're going to talk about the vector equation of a straight line. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So to start off, we are familiar with writing equations of two-dimensional straight lines, right? Of the form y is equal to mx plus c, or ax plus by is equal to c, right? So as well, we can write the equation of a line in vector form, right? And why do we do this? We do this so that we express the position vector of any point on that line, right? So this is what we call the vector equation, right? And its core purpose is for us to express the position vector of any point on the line, right? So there are two basic things that we need for us to come up with the equation of a line in vector form, or to come up with the vector equation, right? We need any position vector of any point, right, which lies on the line, and we also need any vector, right, which runs along the line, right? In other words, we need the direction vector and the position vector, right, of any point along the line. Right? So the vector equation of a straight line passing through a point, right, with position vector A and the direction vector B is written as R is equal to A plus TB, right? Where T is basically a scalar, right? And A, we're saying there's a position vector that lies on the line. B being the direction vector which runs along the line, right? So this is how we can express the position vector of any point along a straight line, right? So now I'd like to achieve these questions, right? So for number one, the question says the vector equation of the line L is R is equal to 2, 3 minus 1 plus t times 4 minus 5, 10, right? So question now says, write down the coordinates of the points A, B, C on the line, which correspond to the following values of t, right? So first of all, when t is equal to 0, right, this is 1a. When t is equal to 0, we need to find the coordinates of the point. So we say this vector equation is giving us the position vector of any point. So for point A first, we're going to substitute when t is equal to 0, such that we've got, and if we substitute for t is equal to 0 here, any number multiplied by 0 gives us a 0. So we know that vector OA, which is the position vector of A, is 2, 3 minus 1, which implies that point A will be 2, 3 minus 1. And then when t is equal to 1, here we need to find OB, which is the position vector of B. When t is equal to 1, we're saying 2, 3 minus 1, right? Then plus, when t is equal to 1, we still have 4 minus 5t. Such that 2 plus 4, we get a 6. And 3 minus 5, get a minus 2. Then minus 1 plus 10, we get a 9. Like this. So point B would be 6 minus 2, then 9. Like this. That's point B. And then when t is equal to minus 3, here we need to find point C. Right? So first of all, if we find the position vector of C, we say that OC is equal to 2, 3 minus 1, then plus, now t is equal to minus 3. So first of all, we just multiply by the scalar amount minus 3. So we're saying minus 3 times 4. So here we're saying plus. Minus 3 times 4, that's minus 12. Then minus 3 times minus 5 is 15. And minus 3 times 10, that's minus 80. Right, so we're carrying out this addition here. 2 minus 12 will give us minus 10. and 3 plus 50, that's an 18, then minus 1 minus 30, that's minus 31. Such that point C would be minus 10, 18, then minus 31, right? So these are the 3 points, A, B, and C, right? And then now question number 2 says in 2 dimension, that's in 2D, find using column vectors a vector equation for first part, the line through the point 4 minus 1 in the direction of vector minus 3, 5. So I'll erase this here. Right, so this is now number 2. And for number 2 is we can see we're given the point, right? We're told that this line passes through the point 4 minus 1, right? So passing through 4 minus 1, which means that here our A is the position vector of this point, 4 minus 1. And in column 4, we're simply saying R is equal to 4 minus 1 like this. Then plus, here our scalar, we decide to use T, lambda, alpha, beta. So in this case, if we just use T, then B being the direction vector, we're told that it passes through the point 4 minus 1 in the direction of vector minus 3, 5. So minus 3, 5 is our direction vector. So this for 2A. Then for 2B, so that's the equation. Then for 2B, the line joining the points with position vectors 2 minus 5 and 4, 3. So first of all, we need to find the direction vector. So in other ways to find the direction vector, we're simply finding, in other ways, the displacement vector, to say from this vector to that vector. With our direction vector B would be given by 4, 3 minus 2 minus 5. Right, which would be 2, 8. So 2, 8 is our vector B. And then our vector A is the position vector of any point. So we can either use this or that, depending on what we want. So the vector equation will now be R is equal to, in this case, if I decide to use 2 minus 5, saying 2 minus 5 plus, we can pick T, or we can pick another scalar. Let's see, we decide to use S, then direction vector 2, 8. So this will be the vector equation for part D. And now for number 3 says in 3 dimension, right, which is in 3D, find using unit vectors a vector equation for the line passing through A, which is parallel to the vector minus I minus j plus k. So in this case, minus I minus j plus k is our direction vector. And for us to get A being the position vector of any point, in this case, point A will be 2i plus j plus 5k, such that the equation, vector equation, R will be equal to 2i plus j plus 5k, right, and then this will be plus t, which is our scalar, and we'll put our direction vector here, minus I minus j plus k. Alright, so this is simply the vector equation for number 3A. And for 3B, now we're told that the line the line through B, point B being 3, 2, 4, which is parallel to CD, right? Where OC is equal to 6i minus 2j plus 3k, and OD is equal to 5i plus 2j minus k. So in this case, CD is the direction vector, but we need to calculate our CD first. So CD shall be given by, definitely, this shall be given by OD minus OC. So I'm saying 5i minus 6i, that's minus I, and then 2j minus 2j, that's plus 4j, and then minus k minus 3k, plus minus 4k. So those are CD, which is the direction vector. So the equation R will be given by position vector of OB, which is 3I plus 2j plus 4k, right? And then plus T direction vector minus I plus 4j minus 4k. Right, so this will be the vector equation for 3b. Then for number 4, right, there are points A and B of position vectors. A 2 minus 1 3 and B 1 1 1. Question now says find equation of AB. So here we've got A already. We know that A will be the position vector of any point which lies on the line. So we've got these two position vectors. But what we need is B. B being the direction vector. So we shall calculate AB, right, for A. Shall calculate AB, which is our direction vector, which is given by OB minus OA. In other words, this is given by B minus A, which is simply 1 minus 2, that's minus 1, then 1 minus 1, that's a 2, then 1 minus 3, that's minus 2. So this is our vector, direction vector, such that the equation would be R is equal to, here we can decide to use A or B for the direction vectors. So if we use A, right, 2 minus 1, 3 plus T, right, direction vector minus 1, 2 minus 2. So this will be the equation of AB. Right. And then the last part now says find the values of alpha and beta if the point C, which is 3 alpha beta, lies on line AB. Right. So now if we rewrite this as one equation, so let me erase this part. So if we rewrite this as one equation for number 4b, we're saying that R would be equal to 2 minus T, then minus 1 plus 2T, and then 3 minus 2T, right? But we know that position vector of C, which is OC, is 3 alpha beta, right? So this position vector should be equal to that. So now if we simply equate, we're saying 2 minus T is equal to 3, which implies that T is equal to minus 1. Then minus 1 plus 2T is equal to alpha. So T being equal to minus 1, we're saying minus 1 minus 2 is equal to alpha. Then alpha will be equal to minus 3. Then 3 minus 2T is equal to beta. But T being equal to minus 1, we're saying 3 plus 2 is equal to beta. Says that beta will be equal to 5 and alpha is equal to minus 3. Okay, so this was looking at how we come up with the vector equation of a straight line. And please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.